Number 2, you're given f of x. And in part A, you're asked to find the critical values. So critical values happen when the derivative equals 0. So we need to find the derivative first. F prime of x equals, the derivative of x cubed is 3x squared minus 6x minus 9. So we need to set 3x squared minus 6x minus 9 equal to 0. To factor here, all 3 of these numbers are divisible by 3. So let's go ahead and factor out a 3. We get x squared minus 2x minus 3. And then we want to factor the quadratic. We can factor it into x minus 3, x plus 1. Then we need to set each factor that has an x in it equal to 0. We don't have to set this 3 equal to 0 because there's not an x in it. We really can just ignore it. We set x minus 3 equal to 0, x plus 1 equal to 0. So we get x equals 3 and x equals negative 1. So these are the critical values. I'm not sure exactly if she wants the points, which would be the x and y coordinates for each of these or not. I went ahead and found them. That's up to you. I also went ahead and found which one was a maximum and which one was a minimum. But because the question is only asking for critical numbers, it's not asking for minimums and maximums, I think this would be sufficient. If you wanted to find the y values that went with it, you would plug it back into the original function. So if you plug these back into the original function, we get critical numbers at the point 3, negative 32, and negative 1, 0. Like I said, I don't know if she's going to be looking for the x and y coordinates or just the x values, but just know if you do need to find the y coordinate, you plug back into the original function. Part B is asking to determine the intervals in which the function is increasing and decreasing. So that also comes from the derivative. So we've got the derivative 3x squared minus 6x minus 9. And then we've got our critical numbers at 3 and negative 1. So we need to look at a number line. We're going to plot negative 1 and 3. And we need to test numbers in each one of these intervals to see if they're positive or negative. So if we test, let's say negative 2 in the derivative, negative 2 squared is positive 4, then times 3 plus 12 minus 9 gives us 15, a positive 15, which you can do in your calculator. We get a positive there. A number in this interval would be 0. So f prime of 0 that gets us negative 9. So we get negative values in this interval. And then last one, I'll try 4. We get positive 15 again. So we've got positive values here. So anywhere that the derivative is positive, that's where it's increasing. Where it is negative, that's where it's decreasing. So I'm going to say it's increasing on the interval from negative infinity to negative 1. and from +3 to positive infinity. And it is decreasing on the interval -1 to 3. Part C is asking for where f is concave up and concave down. That comes from the second derivative. So if we take the second derivative from the first derivative, we get 6x minus 6. We need to see where the second derivative is 0. So we'll set that equal to 0. And solve for x, we get x equals 1. So again, we're using a number line. We need to test a number less than 1 and a number greater than 1 in the second derivative. So I'll try 0. 6 times 0 minus 6 is -6. So we get negative there. And let's try f double prime of 2. 6 times 2 minus 6 is +6, so we get positive values here. So anywhere the second derivative is negative, that means it's concave down. Anywhere the second derivative is positive, that means it's concave up. So we'll say concave down on the interval from -infinity to 1. And concave up on the interval from 1 to infinity. So there's our answer for part C. Part D is asking to determine any inflection points. Inflection points are where the function changes from concave up to concave down, or from concave down to concave up. So in part C, it changes from concave down to concave up at an x value of 1. So we've got an inflection point at x equals 1. Again, I don't know if she's going to want the actual x and y coordinates for this point, or if x equals 1 is sufficient. If you do want to find the y coordinate for this, you need to go all the way back to the original function, and you get a point of 1, -16.